Welcome to Section 26, Installation of Electrical Equipment. It is your responsibility to understand and apply all requirements of the Canadian Electrical Code Part 1, including those not addressed in the training. Do you want to know how to take this?
I am Harold, your subject matter professional for this learning. I will help you to understand and be able to apply the requirements of this section of the Canadian Electrical Code Part 1.
The aim of this training is to provide new knowledge and to support the development of new skills that you can apply immediately to your job. The purpose is why you are taking this learning. To directly support the purpose, this learning has identified objectives. Here is what you will learn as you take this training. This training is divided into topics. These topics build on each other, so a best practice is to review them in the order they are presented. Save or print a copy of the Quick Reference Guide. It is located in Resources. Use this quick reference guide to take notes and as a practical job aid for this code section.
It is important to think about safety when installing electrical equipment. Some pieces of electrical equipment are designed to be mounted on a floor. If that equipment has an open bottom and the floor has a combustible surface, then the floor surface can be subject to arcing or sparking under fault conditions through the open bottom. Equipment mounted on a floor is acceptable only if the floor surface is covered with non-combustible material, due to it presenting a hazard if the floor surface is combustible. The certification requirements for electrical equipment state that all equipment to be mounted directly over combustible surfaces do not require any additional protection, unless the equipment bears a cautionary marking clearly indicating that additional protection is necessary. Surface must be covered with a steel plate at least 1.6 millimeter thick, extending not less than 150 millimeters beyond the equipment on all sides, if the equipment is marked to require such protection or the equipment is open at the bottom. When installed inside an enclosure, certain types of electrical apparatus can generate a significant amount of heat that can damage the apparatus or reduce its life expectancy. One way of keeping the heat buildup at a satisfactory level is to ventilate the enclosure. Keeping the ventilation open to airflow is also a certification requirement for these ventilated enclosures. Rule 26-006 requires that enclosures that are to be ventilated to avoid overheating are not to be installed in a way that restricts the necessary ventilation. In many cases, electrical equipment such as transformers, capacitors, and motor starters are immersed in a dielectric liquid and installed indoors. Leakage of this dielectric liquid from the equipment into the building or sewer system presents an environmental and fire hazard. Subrule 1 requires that when electrical equipment contains larger quantities of liquid, over 23 liters of liquid in one tank, or over 69 liters in a group of tanks, the environmental and fire hazards become significant, and the equipment is to be in an electrical equipment vault. Subrule 2 gives the requirements for the service room where dielectric liquid-filled electrical equipment containing 23 liters of liquid or less in one tank, or 69 liters or less in a group of tanks, are to be installed in a service room conforming to the requirements of the National Building Code of Canada, provided with metal pan or concrete curbing capable of collecting and retaining all the liquid of the tank or tanks, isolated from other apparatus by fire-resisting barriers, with metal enclosed equipment considered as providing segregation and isolation, and separated from other dielectric liquid-filled electrical equipment by such a distance that, if the liquid in such equipment were spread at a density of 12 liters per square meter, the areas so covered would not overlap, these areas being deemed to be circular if the tank or group of tanks is in an open area, semicircular if the tank is against the wall, and quarter sector if the tank is in a corner. Sub-Rule 3 allows a dielectric liquid-filled motor starter to have the quantities of dielectric liquid specified in Sub-Rule 1 and Sub-Rule 2 doubled. Sub-Rule 4 allows an exception of the requirements of Sub-Rule 2 for capacitors that contain flammable liquids of 14 liters or less in each tank are not required to be installed in an electrical equipment vault or in a service room, provided a metal pan or concrete curbing capable of collecting and retaining all the liquid of the tank or tanks is installed. No other dielectric liquid-filled electrical equipment or any combustible surface or material is within 4.5 meters unless segregated by fire-resisting barriers, with metal-enclosed equipment considered as providing segregation. Each capacitor tank is provided with overcurrent protection to minimize rupture of the case. Sub-Rule 5 allows an exception from the requirements of Sub-Rule 1 for dielectric liquid-filled equipment located indoors with more than 23 liters of liquid in one tank or more than 69 liters in a group of tanks, provided the following additional conditions are met. Equipment is protected from mechanical damage either by location or guarding. Equipment contains a non-propagating liquid having a flash point of 275 degrees Celsius or higher. Equipment other than transformers, a means of absorbing gases generated by arcing inside the case, or a pressure relief device is provided. Transformers with a rating of 25 kVA at 25 Hz or exceeding 37.5 kVA at 60 Hz, a means of absorbing gases generated by arcing inside the tank, or a pressure relief vent is provided, and transformers exceeding 25 kVA at 25 Hz or exceeding 37.5 kVA at 60 Hz are rated at 15,000 volts or more. The service room is accessible only to authorized persons. Appendix B note states that dielectric liquid-filled circuit breakers or switches should have their vents piped directly to an outside area in accordance with the manufacturer's instructions or recommendations. When outdoor dielectric liquid-filled, electrical equipment containing more than 46 liters in any one tank, or a total of 137 liters in a group of tanks, fails under certain conditions of fault, the dielectric liquid can burn in the air. This burning liquid, as well as any leaking dielectric liquid, might reach the building, causing problems for people in the building, people evacuating the building, and the building itself. Except as permitted by Sub-Rule 3, Rule 26-012 requires dielectric liquid-filled electrical equipment containing more than 46 liters in one tank or 137 liters in a group of tanks and installed outdoors shall not be located within 6 meters of any combustible surfaces or material on a building, door or window, or ventilation inlet or outlet. Sub-Rule 2 gives the requirements of how the 6 meters distance in Sub-Rule 1 is to be measured. The distance is to be the shortest line of sight distance from the face of the container containing the dielectric liquid to the building or part of the building. Sub-Rule 3 provides that when the 6-meter distance from the building cannot be maintained, an allowance is made for the equipment to be installed at a distance less than 6 meters from the building, provided a wall or barrier made with fire-resistant surfaces or material that prevents burning liquid from contacting the building is constructed between the building and the equipment. This barrier is in addition to the normal enclosure for the equipment. The location of outdoor dielectric liquid-filled electrical equipment must be accessible to firefighting operations, accessible to authorized personnel who are responsible for servicing and maintaining the equipment, and inaccessible to unauthorized personnel to keep them from contacting the equipment. Section 26 is divided into subsections with rules on installing electrical equipment. Select the subsection to review the requirements. When you have completed all subsections, you can continue to the course summary. An isolating switch is a non-load break switch intended for isolating either a circuit or a piece of equipment from its source of supply. It is not intended either to establish or to interrupt the load current in any circuit. Rule 26-100 requires an isolating switch to be permitted to be located so that a hook stick is required to operate them. Plainly marked to minimize the chance that they will be operated under load, unless A. They are located or guarded so they are inaccessible to unauthorized persons, or they are interlocked so they cannot normally be opened under load. Many larger indoor circuit breakers are immersed in dielectric liquid. The degree of fire hazard is related to the quantity of dielectric liquid used. Rule 26-120 requires
Subrule 1, that the requirements of Rule 26-010 are to be applied to circuit breakers, as well as to any other type of dielectric liquid-filled electrical equipment. If a circuit breaker is installed in an electrical equipment vault, it is to be mounted so that the circuit breaker itself is on the inside of the vault, and only the operating handle is exposed on the outside of the vault.
Subrule 2, that the circuit breaker is to be operable without opening the door of the vault. A fuse is expected to operate under either overload or short circuit conditions. Rule 26-140 requires fuses to be located so that there is no injury to people, damage to property, damage to other electrical equipment, and be capable of being readily inserted and removed from the fuse holders. In low voltage installations, the fuses are typically located in either an externally operated switch or a panel board. For high voltage installations, refer to the appropriate rules in Section 36. When the insulated conductors supplying fusible electrical equipment are allowed to carry higher currents, an increased heating effect occurs inside that equipment enclosure. Zinc link fuses, usually referred to as standard or code fuses, now known as Class H fuses, are an additional source of heat, and the combined heat can cause a premature failure of the equipment. Therefore, Rule 26-142 requires, if higher ampacities are allowed, it is necessary to use Class H fuses with a low melting point designated by the marking D or P on the label, or to use fuses that do not generate as much heat, such as listed in the box on the screen. The approval process is a means of ensuring that capacitors included as a component part of other apparatus operate safely. Capacitors installed to conform to Rules 26-200 to 26-222 are required to be approved, as stated in Rule 2-024. Dielectric liquid-filled capacitors located indoors shall be installed in accordance with Rule 26-010. When de-energized, capacitors automatically drain their stored charge within a specific period. See Rule 26-222. In this process, the bonding circuit not only carries fault current, but must carry the discharge current for the time it takes the capacitor to discharge the stored charge. To allow the bonding circuit to carry the fault current or discharge when required, Rule 26-206 requires that non-current carrying metal parts of capacitors are bonded to the ground. This portion of Section 26 includes Rules 208 through 268 and focuses on capacitors and transformers. Beginning with Rule 26-208, it is required that when capacitors operate on an energized AC system, a surge of current occurs as the capacitor plates are charged and discharged. Since the polarity of the capacitor plates changes every half cycle, there is a small continuous surge on the capacitor's supply conductors if the capacitor is energized. Sub-Rule 1 requires that conductors of capacitor feeder and branch circuits are to have an ampacity not less than 135% of the rated capacitor's current. It is helpful to first know that all capacitors are manufactured with a tolerance of 0% to plus 15%, allowing a capacitor to draw a current equivalent to 115% of its rating. In addition, the current drawn by a capacitor varies directly with the line voltage, and any variation in the line voltage from a pure sine waveform causes the capacitor to draw an increased current. Where a branch circuit supplies two or more capacitors, the overcurrent device protecting the conductors of the branch circuit shall be considered as protecting the taps made to supply single capacitors, provided that the tap is not more than 7.5 meters long and its conductors comply with Sub-Rule 1 and have an ampacity not less than 1/3 that of the branch circuit conductors from which they are supplied. Time for an activity. Select your response and click Submit. It is essential to address overcurrent protection factors and to protect capacitors against bursting if a unit becomes defective. Individual capacitor overcurrent protection or the single protection of a capacitor bank is typically used. This involves coordinating the time current or tripping the overcurrent protection with those of the container, with respect to the bursting caused by the generation of gas pressure under fault conditions. It is necessary to consider the available fault current of the circuit and the proper connection of the capacitors in the circuit, whether in parallel, series parallel, or Y-connected with a floating neutral, when selecting protection. Improper capacitor connections can also cause overvoltage on adjacent units upon failure of a unit. Rule 26-210 requires that the overcurrent protection be set as low as practicable without causing nuisance tripping of the overcurrent device, but not to exceed 250% of the capacitor's rated current for feeders or branch circuits supplying capacitors. It is very important that disconnecting of capacitor feeders or branch circuits be carried out very carefully. Rule 26-212 ensures this safety by enforcing the following requirements. Sub-Rule 1 requires that anyone servicing a capacitor is to be able to safely disconnect it from its feeder or its branch circuit and do so without interrupting other loads. Sub-Rule 2 requires that disconnecting means for capacitor feeder and branch circuits are to be within sight of and not more than 9 meters from the capacitor, unless the disconnecting means can be locked in the open position. Due to the stored energy in a capacitor, Sub-Rule 3 requires a warning notice to be affixed to the disconnecting means used on circuits having capacitors only, stating, "The circuit has capacitors and a waiting period of 5 minutes is necessary when the circuit is open to allow the automatic discharge function of the capacitor time to discharge the stored energy, after which the capacitor is to be discharged by grounding the capacitor before handling. To prevent heat buildup in the disconnected means, Rule 26-214 requires that the disconnecting means for a capacitor feeder or branch circuit is to have a continuous rating of not less than 135% of the rated current of the capacitor.
Contactors used for the switching of capacitors shall have a current rating not less than 135% of the rated capacitor current for open-type contactors. Due to heat dissipation, extra capacity is required if contactor is enclosed. Contactors used for the switching of capacitors shall have a current rating not less than 150% of the rated capacitor current for enclosed-type contactors.
There are special provisions that need to be followed when a capacitor is provided for an individual motor according to Rule 26-218, where a capacitor is connected to the load side of a motor circuit disconnecting means. Individual disconnecting means for the capacitor need not be provided. The rating of the disconnecting means, the overcurrent device, and the size of the motor circuit conductors need not be greater than would be required without the capacitor. And the ampacity of the conductors connecting the capacitor to the motor circuit shall be in accordance with Rule 26-208 and shall not be less than 1/3 that of the motor circuit conductors. Where a capacitor is connected on the load side of a motor controller, the rating of the capacitor shall not exceed the value required to raise the no-load factor of the motor to unity. The rating or setting of the overload device shall be reduced to a value corresponding to the current obtained with the improved power factor. Individual overcurrent protection for the capacitor need not be provided. The motor shall not be subject to star-delta starting, auto-transformer starting, or switching service such as plugging, rapid reversals, reclosings, jogging, or other similar operations that generate overvoltages and overtorques, and time delay devices shall be installed in the motor control circuit of motors driving high inertial loads, so that the motor cannot be restarted until the residual voltage is reduced to 10% of the nominal value. When in use, capacitors build up a stored charge. Upon disconnection from its source of supply, a capacitor holds that charge for a period. As a result, people servicing the electrical equipment can receive a severe shock or the equipment can be damaged, unless some means is provided for draining off the stored charge from the capacitor. Rule 26-222 requires there be a means of draining the stored charge or residual voltage left when the capacitor is de-energized. The stored or residual voltage be reduced to the following: for low voltage capacitors, or for high voltage capacitors, the discharge circuit should be connected to the terminals of the capacitor bank, or automatically connected to the capacitor when it is de-energized. The discharge circuit shall not be switched or connected to the capacitor by manual means. Motors, transformers, and other electrical equipment capable of constituting a suitable charge path connected directly to capacitors without the interposition of a switch or overcurrent device constitute a suitable discharge path. Table 26-1 shows the method to determine the maximum overcurrent device size and the minimum conductor size for a capacitor or capacitor bank installation. Types of transformers and requirements for the enclosures for transformers, conductor entry into transformer enclosures, mechanical protection, and the airspace surrounding dielectric liquid-filled transformers are covered in Rule 26-240. Click each subrule on the screen to learn more. Subrule 1 defines transformer as a single-phase transformer, a polyphase transformer, or a bank of 2 or 3 single-phase transformers connected to operate as a polyphase transformer. There are numerous unit substations being designed, constructed, and installed as complete integrated assemblies approved in accordance with SP 1000. Subrule 1B defines a unit substation as an integrated unit consisting of one or more transformers, disconnecting means, overcurrent devices, and other associated equipment, each contained in a suitable enclosure designed and constructed to restrict access to live parts. Transformers such as those used in Class II circuits, doorbell transformers, and ballasts in electric discharge luminaries are not covered in this subsection. Subrule 2 requires that live parts not be exposed unless the transformers are accessible only to authorized personnel. In other words, transformers are to have all live parts enclosed unless they are isolated by elevation, location in a lockable transformer vault, or being surrounded by a suitable fence such as chain link. Subrule 3 recognizes that the temperatures in the enclosure of an air-cooled or dry-type transformer can exceed 30 degrees Celsius, and the surface temperatures of the core and coil assemblies can exceed 90 degrees Celsius. If the conductors or cables enter the transformer enclosure through the top, the conductors or cables insulation can fail due to heat buildup at the top of the transformer. Therefore, conductors and cables used to connect air-cooled transformers are not allowed to enter the transformer enclosure through the top, unless the transformer is marked to allow top entry. Subrule 4 requires that transformers are to be protected from mechanical damage to ensure that motor vehicles do not accidentally bump into and damage a transformer located outdoors near a driveway or a loading platform. Subrule 5 is an installation requirement for the airspace surrounding dielectric liquid-filled transformers. The purpose of this requirement is to ensure adequate air circulation around the transformer and any adjacent combustible and non-combustible wall surfaces. Therefore, Subrule 5 requires an airspace of 150 millimeters between dielectric liquid-filled transformers and between the transformers and adjacent surfaces of combustible material. This airspace allows air circulation to keep the dielectric material from overheating. See the diagram on the screen for clearances around oil-filled transformers. Note, when transformers are mounted on combustible surfaces, the requirement of Rule 26-004 is to be met. Installing transformers and unit substations outdoors must be completed carefully. Rule 26-242, Subrules 1 and 2, point out the safety standards for installation. Transformers or unit substations, including their conductors, cables, and control and protective equipment, installed outdoors are required by Subrule 1 to A. Be installed in accordance with Rule 26-014 if they are dielectric liquid-filled. B. Have the bottom of their platform not less than 3.6 meters above ground if they are isolated by elevation. C. Have the entire installation surrounded by a suitable fence in accordance with Rules 26-300 to 26-324 if they are not isolated by elevation or housed in suitable enclosures, and D. Have conspicuously posted suitable warning signs indicating the highest voltage employed, except where there is no exposed live parts. Dielectric liquid-filled pad-mounted distribution transformers, either independently installed or forming part of a unit substation, are required by Subrule 2 to be installed at least 3 meters from any combustible surface or material on a building and a minimum of 6 meters from any window, door, or ventilation inlet or outlet. Subrule 2 also allows for an exemption from the 3-meter and 6-meter distance requirements when a wall or barrier with non-combustible surfaces or material is constructed between the transformer and any door, window, ventilation opening, or combustible surfaces, or The transformer is equipped with an integral current limiting device and a pressure relief device, and sufficient space is available to gain entrance to the transformer and do work around the transformer such as painting, attaching slings for removal, etc. The required working spaces are at least 3 meters on the access side of the transformer, and on all other sides, 1 meter for three-phase transformers and 0.6 meters for single-phase transformers. If a dielectric liquid-filled transformer case ruptures, the presence of the liquid can present an additional hazard to the building since it can collect or pool on the roof. The degree of that hazard depends on the flammability of the liquid. Rule 26-244 establishes additional requirements for a dielectric liquid-filled transformer installed on the roof of a building. Appendix B, note to Rule 26-244, provides assistance in determining how the liquid in the transformer is to be classified. Subrule 1 requires that dielectric liquid-filled transformers mounted on a roof are to be installed in an electrical equipment vault and not supported by combustible construction. The rationale is that a fire inside the building can weaken the structure, causing the transformers to crash through the roof and substantially increase the fire load. Subrule 2 states that a vault is not required when the liquid used in the transformer is the non-propagating type with a flash point equal to or greater than 275 degrees Celsius. The transformer is to be located so that it is not placed adjacent to doors or windows or within 4.5 meters of discharge vents for combustible materials or gases, as shown by the diagram on the screen. Since fully loaded dry core transformers can produce a substantial amount of heat, these types of transformers are not to be mounted too close together or to surrounding surfaces, which can overheat both the transformers and the surrounding combustible surfaces. See both diagrams on the screen. The Rule 26-246 requires transformers of the dry core, open ventilated type, shall be mounted so that there is an airspace not less than 150 millimeters between transformer enclosures and between a transformer enclosure and any adjacent surface except floors. The minimum permissible separation between the transformer enclosure and the adjacent surface shall be 300 millimeters. The minimum permissible separation between the enclosure and the mounting wall shall be 6 millimeters if the adjacent surface is made of A. non-combustible material, B. combustible material adequately protected by non-combustible heat-insulating material other than sheet metal, or C. combustible material shielded by grounded sheet metal with an airspace of not less than 50 millimeters between the sheet metal and the combustible material. Dry-type transformers not of the sealed type shall not be installed below grade level unless adequate provision is made to prevent flooding. Dry-type transformers not of the sealed type shall be installed in such a manner that water or other liquids cannot fall into the windings. The Rule 26-246 also requires that transformers other than the sealed type are to be placed where they are not subject to damage by water. To service power and distribution transformers safely and without interruption of other loads, a disconnecting means shall be installed in the primary circuit of each power and distribution transformer. The selection of overcurrent protection devices, such as fuses and circuit breakers, is made more complicated when high inrush currents have to be tolerated. The overcurrent protection is to react quickly to overload or short circuit faults, but should not interrupt the circuit when the usually harmless inrush current flows. When a transformer is first energized, an inrush current approximately 10 to 50 times higher than the rated transformer current can flow for several cycles. For large transformers, the inrush current can last for several seconds. The high currents occur to energize the transformer core. The steady rate magnetizing current of a transformer is very low, but the momentary current, when it is first energized, can be quite high. Overcurrent devices located on the secondary side of a transformer do not protect the transformer against a short circuit condition that can occur on the primary windings. Consequently, overcurrent protection is required in high voltage transformers on the primary side. The multiplier or correction factor used to size the maximum individual overcurrent device. Select to learn more. Select to learn more. In Subrule 1, each undergrounded conductor of the transformer feeder or branch circuit supplying the transformer shall be provided with overcurrent protection rated or set at not more than 150% of the rated primary current of the transformer, except as permitted in Subrules 2 to 6. In Subrule 2, where the rated primary current of a transformer is 9 amps or more, and 150% of this current does not correspond to a standard rating of a fuse or non-adjustable circuit breaker, the next higher standard rating shall be permitted. Or, where the rated primary current of a transformer is less than 9 amps, an overcurrent device rated or set at not more than 167% of the rated primary current shall be permitted, except that where the rated primary current is less than 2 amps, an overcurrent device rated or set at not more than 300% of the rated primary current shall be permitted. Subrule 3 states that an individual overcurrent device shall not be required where the feeder or branch circuit overcurrent device provides the protection specified in this rule. Subrule 4 requires a transformer having an overcurrent device on a secondary side rated or set at not more than 125% of the rated secondary current of the transformer, shall not be required to have an individual overcurrent device on the primary side, provided the primary feeder overcurrent device is rated or set at not more than 300% of the rated primary current of the transformer. Where the rated secondary current of a transformer is 9 amps or more, and 125% of this current does not correspond to a standard rating of a fuse or non-adjustable circuit breaker, the next higher standard rating shall be permitted. Or, less than 9 amps, an overcurrent device rated or set at not more than 167% of the rated secondary current shall be permitted. Subrule 6. A transformer equipped with thermal overload protection by the manufacturer and arranged to interrupt the primary current shall not be required to have an individual overcurrent device on the primary side if the primary feeder overcurrent device is rated or set at a value not more than 6 times the rated current of a transformer for a transformer having not more than 7.5% impedance, or not more than 4 times the rated current of the transformer for a transformer having more than 7.5%, but not more than 10% impedance. Dry-type transformers usually do not have the overload capacity of dielectric liquid-filled transformers. As a result, Rule 26-254 describes each requirement for overcurrent protection. Take a look at the example. Subrule 1. Except as permitted in Subrule 2, each undergrounded conductor of the transformer feeder or branch circuit supplying the transformer shall be provided with overcurrent protection rated or set at not more than 125% of rated primary current of transformer, and this primary overcurrent device shall be considered as protecting secondary conductors rated at 125% or more of rated secondary current. Subrule 2. Notwithstanding Subrule 1, a transformer having an overcurrent device on the secondary side set at not more than 125% of the rated secondary current of the transformer shall not be required to have an individual overcurrent device on primary side, provided primary feeder overcurrent device is set at not more than 300% of rated primary current of transformer. Subrule 3 requires that where a value not exceeding 125% of rated primary current of transformer, as specified in Subrule 1, does not correspond to standard rating of overcurrent device, the next higher standard rating shall be permitted. Time for a scenario. Please read the scenario and follow the instructions to submit your answers. How well did you do? It is important to understand conductor size for transformers. Subrules 26-256-1 and 2 explain the requirements. Subrule 1 requires that conductors supplying transformers have an ampacity rating not less than 125% for a single transformer and not less than the sum of the rated primary currents of all the transformers, plus a 25% of the rated primary current of the largest transformer in a group. Subrule 2 requires secondary conductors connected to transformers to have an ampacity rating not less than 125% of the rated secondary current of the transformer for a single transformer, or not less than 125% of the sum of the rated secondary currents of all the transformers operated in parallel. Subrule 3. Notwithstanding Subrules 1 and 2, primary and secondary conductors shall be permitted to have an ampacity rating not less than that required by the demand load, provided that they are protected in accordance with Rules 14-100 and 14-104. Subrule 4 provides that where the transformer overcurrent protection is more than 125% of the rated primary or secondary current in accordance with Rule 26-250 or 26-254, Subrule 3, the primary and secondary conductors connected to transformer shall be protected in accordance with Rules 14-100 and 14-104, which may result in a larger conductor size, as required by Rule 26-250, Subrules 1 and 2. Subrule 5 provides where multi-rating transformers are used, the primary and secondary conductors shall have an ampacity rating not less than 125% of the rated primary and secondary current of the transformer at the utilization voltage. The table shows the minimum size, or primary and secondary conductors size, based on the size of the transformer and demand load. The first figure on the screen shows steps for determining winding amps, along with the formulas for conductor ampacity ratings. The second shows the results of the calculations from Figure 1. The requirements for the purpose of transformer overcurrent protection and conductor sizes are discussed in Rule 26-258. The continuous load as determined from the calculated load connected to the transformer's secondary shall not exceed the values specified in Rule 8-104, Subrule 5, or Subrule 6, when determining compliance with the requirements of Rule 8-104 for continuous loads. It is not the rating of the transformer that is used, but rather the load connected to the transformer secondary. For the purpose of transformers overcurrent protection and conductor size selection, in accordance with Rules 26-250 through 256, the continuous load, as determined from the calculated load connected to the transformer secondary, is not to exceed the values specified in Rule 8-104, Item 5, or Item 6. When an overcurrent protection device rated for continuous operation at 80% is installed in the transformer circuit, when free air rated single conductors are being used, a derating of 70% is used to determine the amount of continuous plus non-continuous loads that can be connected to the overcurrent device. Appropriate overcurrent protection for instrument voltage transformers are discussed in Rule 26-260, except under the conditions of Sub-Rule 2 and 3. Instrument voltage transformers shall have primary fuses rated not more than A. 10 amps for low voltage circuits and B. 3 amps for high voltage circuits. 2. Primary fuses shall not be installed where they may be connected in the grounded primary neutral connection of a Y or open Y connected voltage transformers. 3. Primary fuses shall be permitted to be omitted. A. Where the transformers are protected by adequate power fuses or other adequate protective devices for clearing equipment failure, and convenient means are provided for disconnecting the transformers on the primary side. B. Where voltage transformers and meters, operating at low voltage and installed in suitable enclosures, are used in place of self-contained meters, or C. Where both voltage and current transformers are supplied by the manufacturer in a single enclosure filled with an insulating medium, which may be air for use on low voltage circuits if the enclosure is non-combustible, and where 1. The primary terminals outside the enclosure are common to both voltage and current transformers, and 2. The enclosures are installed outdoors if filled with an insulating medium that will burn in air. Each transformer shall be provided with a nameplate bearing the following marking as specified by Rule 26-262. Manufacturer's name. Rating in kilovolt amperes. Rated full load temperature rise. Primary and secondary voltage ratings. Frequency in hertz. Liquid capacity, if of the liquid-filled type. Type of liquid to be used. Rated impedance, if of the power or distribution type, and basic impulse insulation level, BIL, for transformers rated 2.5 kV voltage class and higher. Auto transformers are transformers in which part of the primary and secondary windings are common to primary and secondary circuits. The use of an auto transformer makes it possible to use a piece of electrical equipment rated for a voltage when it is not readily available from the supply authority. However, an auto transformer does not provide electrical isolation between its windings, primary and secondary, as a power or distribution transformer does.
As a result, Rule 26-264 requires auto transformers to not be connected to interior wiring systems, other than a wiring system or circuit used wholly for motor purposes, unless
the system supplied contains an identified grounded conductor solidly connected to a similar identified grounded conductor of the system supplying the auto transformer. The auto transformer is used for starting or controlling an induction motor, or the auto transformer supplies a circuit wholly within the apparatus that contains the auto transformer. Notwithstanding Sub-Rule 2, auto transformers shall be permitted for fixed voltage transformation in circuits not incorporating a grounded circuit conductor. For example, if a building has a 120-208 volts three-phase supply, but there is a need to provide for a piece of electrical equipment rated at 240 volts, an auto transformer can fulfill this need as shown in the diagram showing circuitry for an auto transformer. Another type of transformer are zigzag transformers. Zero-sequence filters are zigzag or otherwise wound transformers used in a three-phase, four-wire system to control unbalanced loads that are caused by loads having non-linear voltage current characteristics, harmonics. In these installations, the neutral conductor can carry more current than the unbalanced current from other ungrounded conductors of normally balanced circuits of single-phase, three-wire, and three-phase, four-wire systems. Note the location of harmonic filters diagram. Appendix B, note to Rule 26-266 indicates the current in the neutral conductor can be 3 times the current flowing in the phase conductor. If the neutral conductor is not sized to carry this current, It can cause serious heating problems in equipment and conductors. Sub-Rule 1. A zero-sequence filter means a zigzag or otherwise wound transformer installed to reduce unbalanced current in a three-phase, four-wire circuit. Sub-Rule 2. Ampacities of conductors supplying zero-sequence filters, in conformance with Rule 4-004, shall be based on the neutral conductor being a current-carrying conductor. Sub-Rule 3. Requires the phase/undergrounded conductors to the filter to have a minimum ampacity rating of 125% or 1.25 times the rated primary current of the filter. Sub-Rule 4 requires the neutral conductor to have a minimum ampacity rating of 125%, 1.25 times the rated neutral current of the filter. Sub-Rule 5. Overcurrent protection for the filter shall not exceed 125% of the rated primary current. Sub-Rule 6. The overcurrent protection required by Sub-Rule 5 shall be equipped with an integral device arranged to activate a warning signal or alarm when operation of the overcurrent protection occurs. Time for an activity. Select your response and click Submit. To minimize the liability and risk of dangerous contact or approach by people or objects, fences are used outdoors to guard electrical equipment in high-voltage substations. Rule 26-300 provides requirements for such fences as shown in the diagram. To minimize the liability and risk of dangerous contact or approach by people or objects, fences are used outdoors to guard electrical equipment in high-voltage substations. Rule 26-300 provides requirements for such fences as shown in the diagram. Requirements of the NBC and other appropriate sections of the Code, including Section 36, for high-voltage installations are outlined in Rules 26-350 to 356. Many of the larger units of electrical equipment, such as transformers and capacitors, are filled with dielectric liquid. Depending on the quantity of liquid involved, the equipment might need to reside in an electrical equipment vault. For the purposes of rules pertaining to the construction of electrical equipment vaults, the single word vault or vaults shall be understood to have the same meaning as electrical equipment vault or vaults. Vaults shall not be used for storage purposes. Lightning arresters shall be installed in every distributing substation in locations where lightning disturbances occur frequently, and no other adequate protection is provided. Lightning arresters installed for the protection of utilization equipment shall be A. Permitted to be installed inside or outside buildings or enclosures containing equipment to be protected, and B. Isolated by elevation and closed or otherwise made inaccessible to unauthorized persons. To prevent fire and shock hazards from lightning arrestor installations, Rule 26-402 requires that they are to be located away from unprotected equipment, passageways and corridors, combustible materials in or on buildings, and in separate areas conforming to requirements of vaults when the arrestor contains oil. Due to the high voltages involved, Rule 26-408 requires that the path to ground is to be as short and straight as practicable. The aim is to keep the current from jumping from one object to another every time it jumps, resulting in extensive damage. Since the surge is directed to follow a predetermined low impedance path, That path is to be kept as far as possible from the regular electrical equipment to minimize any possible damage. The lightning arrestor is also to be connected by, at a minimum, a number 6 AWG copper conductor. A transient volt surge is a momentary voltage surge on a single or power line that lasts for a short time. It can produce false signals or triggering impulses and cause insulation or component breakdown and failures. Rule 26-420 addresses low voltage surge protectors and requirements for safe use. Lightning surge suppressors have been used successfully for many years to prevent damage to electrical installations from direct and indirect lightning strikes, but they do not operate fast enough to prevent damage or disturbances from transient voltage surges. Low-voltage surge protection devices, or transient voltage surge suppressors, are surge suppression products designed to repeatedly suppress transient voltage surges on 50 and 60 Hz power circuits on low-voltage systems, those not exceeding 750 volts. To prevent a fire hazard inside a building due to damage to the low-voltage surge protector or the conductors feeding it, overcurrent protection is necessary when low-voltage protectors are installed inside a building. To enable low-voltage surge protectors to divert the damaging high-voltage spikes or transient voltage to ground, the impedance of the conductors feeding the low-voltage surge protector are to be kept to a minimum. The conductors between the equipment being protected and the low-voltage surge protector should be kept as short and as straight as possible. The manufacturer's specifications should be consulted for the maximum length of conductors. The location of panel boards is important due to safety considerations. Rule 26-600 requires panel boards to contain overcurrent devices protecting branch circuits against overload and short circuit, and serve as a disconnecting means for branch circuits. Are to be in areas where they are not subject to damage or abuse, and are readily accessible when necessary. Sub-Rule 1 requires that a panel board be located to be reached when necessary. A panel board is not to be located in coal bins, clothes closets, bathrooms, stairways, high ambient rooms, dangerous or hazardous location, or undesirable place where articles piled up in front interfere with access and constitute a fire hazard. Receptacles are not to be located in front of a sink or behind a sink unless you have a minimum of 450 millimeters between the sink and the wall behind the sink. Grounding-type receptacles are permitted to be installed, provided receptacle is protected by a GFCI Class A type. The bonding conductor cannot extend from a receptacle that is protected by a GFCI Class A type to any other outlet. Receptacles having CSA configuration 5-15R or 5-20R installed within 1.5 meters of sinks, wash basins with drain pipe, bathtubs, or shower stalls protected by a GFCI Class A type, except where it is intended for a stationary appliance designated for location and located behind stationary appliance, inaccessible for use with general-purpose portable appliances. Time for an activity. Select your response and click Submit. Rule 26-704, Sub-Rule 2, states that all outlets installed outdoors less than 2.5 meters from grade are required to have GFCI protection. All receptacles of CSA configuration 5-15R and 5-20R shall be tamper-resistant receptacles and marked as such according to Rule 26-706 when receptacles are installed in child care facilities, guest rooms and guest suites of hotels and motels, preschools and elementary education facilities, and dwelling units.
Receptacles dedicated to stationary appliances, such that the receptacle is rendered inaccessible, or those located 2 meters above the floor or finished grade, are not required to be tamper-resistant, located above 2 meters.
Receptacles provided on the outside of buildings that are exposed to weather are generally used for outdoor appliances that typically get used when the weather is good. The wet location only when cover closed, weatherproof covers, or the equivalent, when required to be used on these receptacles, only keep the moisture from entering the enclosure and or the receptacle when the appliance plug is not inserted into the receptacle, such as when the cover is closed. The reality is that there are many instances when these receptacles are used for items that remain unattended for long periods, such as automobile heaters, electric vehicle charging stations, and seasonal decorative lighting. In such cases, the appliance plug remains inserted into the receptacle, which leaves the weatherproof cover open, exposing the receptacle to all types of weather conditions. When used in this fashion, there is a risk that long-term exposure to moisture can cause the receptacle to corrode, and if the receptacle is equipped with GFCI protection, that protection might malfunction, creating a fire and shock hazard. In some cases, these receptacles can be installed where they are protected from the weather, such as under an eave or an overhang. If the face of the receptacle is likely to be exposed to the weather, such as rain or snow, Subrule 1 requires that the wet location cover plate marked for extra duty is to be used. CSA C22.2, number 42.1, has additional testing requirements for wet locations receptacle covers suitable for whether or not plug is inserted into the receptacle. Receptacle covers meeting these requirements are rated and marked extra duty. To prevent moisture from entering the enclosure, Subrule 2 requires that the covers for receptacles of CSA configurations 5-15R, 5-20R, 5-20RA, 6-15R, 6-20R, and 6-20RA that are exposed to the weather be for wet locations, whether or not the plug is inserted into the receptacle, and are to be marked extra duty, with the marking being visible after installation. Note the diagram on the screen showing a wet location cover plate with extra duty marking. Subrule 3 allows the covers for selected receptacles of CSA to be marked wet location only when cover closed, or the equivalent when installed facing downward at an angle of at least 45 degrees or less from the horizontal, or installed at least 1 meter above finished grade or floor level and not in a wet location. If a duplex receptacle is installed in a surface-mounted outlet box, Subrule 4 requires that the cover plate be held in place by 4 screws or the equivalent. If a single mounting screw is used, objects can catch on the edge of the cover, and it can be pulled away from the box, breaking the weatherproof seal. When, due to exposure to weather, wet location cover plates are used in flush-mounted outlet boxes, Subrule 5 requires that the covers be fitted to make a proper weatherproof seal. Therefore, if a duplex receptacle is installed in a flush-mounted outlet box installed in accordance with Rule 12-3016, the cover can be held in place by a single screw in the center of the cover. Time for an activity. Select your response and click Submit. Time for an activity. Select your response and click Submit. Rule 26-710 specifies requirements for the maintenance of equipment on rooftops such as HVAC and similar equipment. Requirements for sump pump receptacles can be found in Rule 26-712. For clarification on flood elevation, refer to the definition in Section 0. Rules 26-802 to 26-808 apply to circuits supplying power for the operation and control of non-portable heating equipment that uses solid, liquid, or gaseous fuel. Conductors used with fuel-burning electrical equipment must be adequately protected from mechanical damage. Rule 26-802 requires cable for all branch circuits or tap conductors within 1.5 meters from the floor shall be adequately protected from mechanical damage. Some of the basic requirements for fuel burner safety control circuits are specified in CSA C22.2, number 3. The addition of other controls in the safety control circuits can create a safety hazard if these controls fail, thus negating the safety effect provided by the safety control circuits. The intent of Rule 26-804 is to require safety controls for gas and oil-fired equipment to be installed in accordance with CSA C22.2, number 3. Appendix B, note to Rule 26-804, lists the requirements from CSA C22.2, number 3, pertinent to installation of the safety control circuits. Due to the importance of heating equipment in a building, Rule 26-806 focuses on safety requirements for the use of power with electrical heating equipment. Sub-Rule 1 requires, except as permitted by Sub-Rule 3, all electric power for the heating unit and associated equipment operating in connection with it shall be obtained from a single branch circuit that shall be used for no other purpose. For the purpose of this rule, Sub-Rule 2 allows for circulating pumps and similar equipment not be considered as associated equipment, provided such equipment is not essential for the safe operation of the heating unit. As noted, Sub-Rule 3, as required by Sub-Rule 1, does not apply to a water heater using a gaseous fuel. Sub-Rule 4 allows the branch circuit to be tapped as necessary to supply the various pieces of associated equipment. However, there shall be no overcurrent protection supplied in the tap to any piece of associated equipment the operation of which is essential to the proper operation of the heating unit, unless the control equipment is of such a nature that the heating unit will be shut down if the associated equipment fails to function due to the operation of the overcurrent device. Sub-Rule 5 requires a suitable disconnecting means to be provided for the branch circuit. Sub-Rule 6 allows for a disconnecting means to be a branch circuit breaker at the distribution panel board, providing the panel board is located between the furnace and the point of entry to the area where the furnace is located. In Sub-Rule 7, when a separate switch is required due to the unsuitable location of the branch circuit breaker, it shall A. Not be located on the furnace, nor in a location that can be reached only by passing close to the furnace, and B. Be marked to indicate the equipment it controls. Submersible pumps are to be installed in accordance with the manufacturer's instructions, Rule 26-954, or 26-956, as applicable. In keeping with the definition for submersible pumps given in Rule 26-950, many sump pumps and sewage pumps are classified as submersible pumps. Deep well submersible pumps in wells are outlined in Rule 26-954. Item A requires that a power supply cable from the wellhead to the pump shall be marked -40 degrees Celsius and shall be submersible pump cable. twisted assemblies of type RWU75, RWU90, TWU, or TWU75, or type SOW, G, G-GC, or W. Item B requires deep wells have a cable going down the well to the discharge pipe supported at spacing no greater than 3 meters. Without such support, the weight of the cable puts too much strain on the connectors at the wellhead. To ensure that electrical equipment is properly bonded to ground, a separate bonding conductor is usually provided. Item C requires supply cables to be run from the wellhead to the main distribution panel board in accordance with the requirements of Section 12. Item D allows the discharge pipe to ground the pump when it is connected to the equipment bonding conductor at the wellhead. Installation safety must be provided as required by Rule 26-956 to access a submersible pump and limit hazard to people in the water. Installing submersible pumps in bodies of water is permitted if the voltage supplying the submersible pump does not exceed 150 volts to ground. In addition, ground fault protection shall be provided to de-energize all normally ungrounded conductors supplying the submersible pump, with a ground fault current trip setting adjusted to function as low as practicable to permit normal operations of the pump. But in no case shall the ground fault current setting be greater than 10 milliamps for an operating time period not exceeding 2.7 seconds. Sub-Rule 2 requires that submersible pumps installed in bodies of water are permitted to operate at voltages exceeding 150 volts to ground where a deviation has been allowed in accordance with Rule 2-030. The operating voltage does not exceed 5.5 kilovolts. The electrical installation is maintained by qualified electrical maintenance staff and the area around the submersible pump is protected from access by the public by fencing, cribbing, or isolation and is so marked. It is important to note that branch circuits supplying permanently connected data processing units shall not supply any other types of loads.
You covered a lot in this course. This summary helps you to recall the main concepts and requirements of this code section.